We started talking about the carry save addition, so we will continue that topic. Okay. So, I am teaching directly from Hamacher. If you remember correctly, in last class we talked about, let us say we have a multiplicand. So, we can write M0, M1, M2, M3. So, 4 bit multiplicand. So, this is we can say multiplicand, and then we have multiplier Q0, Q1, Q2, Q3. Okay. Now, naturally what we do it, we multiply Q0, M0, Q0. So, this is nothing but AND, right. So, then this will be M1 Q0, this will be M2 Q0, M3 Q0. Then we start with M0 Q1, then M1 Q1, M2 Q1, M3 Q1. Then with Q2, M0 Q2, M1 Q2, M3 sorry M2 Q2, M3 Q2. Then M0 Q3, M1 Q3, M2 Q3, M3 Q3. So, this will be called product 0, this will be product 1, this will be product 2, product 3, product 4, product 5, 6, and then this should be product 7. So, if any carry out come from here. Okay. Now, objective of this carry save addition is that whenever we add, see whenever say let us say we add this number, then what do we do it, or we add this 4 summand, then carry should propagate on the left side. Okay. For this one we should have a circuit. So, normal circuit how you can draw it, but we have to remember this multiplication part, then we will draw a simple circuit for performing the addition. Okay. Basically objective to add, this is one summand, this is another or partial product PP0, PP1, PP2 and PP3. As you know, it depends on the number of bits in the multiplier. So, now what you do it, we will use simple full adder, because we are not using any carry look ahead adder for performing this one. So, why we are not doing that also we will show it. Say initial we will start with M0 Q0, then we have M1 Q0, then M2 Q0, M3 Q0, that we can get using AND gate. Okay. So, that circuit we are showing. So, we are not showing this part, that how we are getting AND gate. So, that is simple. Okay. Now, what we can do it, so this will be our P0. Now, what we can do it here, we can have a full adder. Okay. So, we can have a full adder. Full adder one input will be taken from M1 Q0. Okay. So, we will have another full adder, this carry will go here, we have another full adder, this carry will be here. So, we have another full adder here. Okay. So, here we do it. So, we got the first PP here, PP 0. Now, what you do it? If you go back here, so this is PP 0, we got it. Now, what we have to do? We have to add with PP 1 for this product, directly it will be P 0. So, therefore, here what we have to do? P 0 Q 1 should be added with M 1 Q 0. So, M 1 Q 0 should be added with what? M 0 Q 1, it should be added M 0 Q 1. Okay. This should be 0, this is 3 input full adder. Okay. Next here we take one input here. Next what you do it? If you come back here, we will have here M2 Q0 is already there and then M1 Q1. So, here we should add M1 Q1, here we add M2 Q2. Okay. Here we should have what? M3 Q1, and then this should be 0. Okay. These input come here. So, this is also full adder. Now, whatever the results, that should be added with third PPE. Okay. But if you carefully here, you see these two term will form the P1. So, therefore, what we can do it directly, whatever the output it will come from full adder. So, that is nothing but P1. Okay. So, now what we have to do? So, these input directly will come one full adder and rest will come from the third row, that is here PP2. So, M0 Q2. So, therefore, you should add here M0 Q2. Obviously, this should be 0 because 3 terms, and that will give you results P2, right. So, P2 is having 3 terms M2 Q0, M1 Q1 and M0 Q2. M2 Q0, M1 Q1 and M0 Q2, M0 Q2, that will give you P2. So, this part is done. Next what you have to do, again we should have another full adder, we should have another full adder, we should have another full adder. Okay. So, one input come directly, it will come here, another input I have to give, that is M1 Q2. Here it should come M2 Q2, this input will come here, this will come M3 Q2. Okay. M0 Q2, M1 Q2, M2 Q2, M3 Q2. Okay. So, next is last term. You should have one term here and then you add M0 Q3. here we have directly term here, you have M1 Q3 M2 Q3. This is all our full adder, simple full adder, carry will take 2 gate delay. Okay. This will be M3 Q3. So, therefore, this will give you P3. P3 will add M0 Q3, M1 Q2, M3 Q0, M2 Q1 and M1 Q1. Okay. So, this 4 term. So, you can see M3 Q0, M2 Q1, M1 Q2 and M0 Q3. So, what you can see here M0 Q3, that is then M1 Q2, M1 Q2 and then M3, this one, right, M2 Q1, M2 Q1, M2 Q1, where is Q1? M2 Q1 and M3 Q0. So, M3 Q0. Okay. So, this 4 term will form P3 and then this will give you P4, this will give you P5, this will give you P6 and whatever the out, that will give you P7. Okay. This is something called ripple carry. We are using carry is just forwarding. Okay. So, therefore, what will be the total gate delay? Gate delay will start from here, even giving input, because we can compute this partial product, each partial product simultaneously with single AND gate. After that, this will take 2 gate delay, this will take 2 gate delay, this will take 2 gate delay, this will take 2 gate delay. After generating 2 gate delay, it has to come here, this will also will take 2 gate delay and again it will take 2 gate delay. So, therefore, 1, 2, 3, 4, 5, 6, 7, 8. So, 8 into 2, 16 plus 1 AND gate. So, total it will take, so 1, 2, 3, 4, 5, 6, 7, 8. So, total 8 into 2 plus 1. So, that will be the total number of gate delay. But question is, in a carry save addition, we will see that each full adder will may come, it can work simultaneously parallelly. So, but in this scenario, if you see, this full adder cannot work until only get input from the previous full adder. Similarly, this cannot work until unless it gets the input from the previous output of the previous full adder. So, therefore, there is a something called relay. What do you want to do it? We should have a circuit where the each full adder in a particular row can work simultaneously. Okay. So, therefore, this entire circuit will change it and that is we will show in the next. Okay. So, what do you do it? So, but this is the basic part, we should not forget this slide. Now, what do you do it? We will change this circuit here. Okay. What do we do it? We will cut this connection here, we will cut this connection here, we will cut this connection here. Instead of what we did it here, say we are adding it and carry we are forwarding here on the left side. Okay. So, that is we did it here, right, we did it in this circuit. We are adding 3 terms and then carry is forwarding on the left side. Instead of that, what we can do it? We can add parallelly, this 4 full adder in a row can add parallelly, and whatever the carry will come, we will propagate on the below row. instead of in the same row we can propagate to the below row, but result will not be affected. Okay. So, therefore, this part whatever I am cutting it here, that should be added into the, as it will act as the input of the full adder. So, therefore, we will have a different circuit where this that connection will not be there. However, the output of the full adder, it should be propagated to the row below. Okay. So, it is better to have a different circuit, but this is the basic, you need to remember how we are changing it here. So, here we go. So, what is that? It has, let me explain here. So, M0 Q0, there is no need for this one. So, P0 will get it, M1 Q0, M0 Q1. Okay. So, there 3 input is fine, we will get P1, but these output. So, I can show you one. So, there should not be a connection. Instead of that, what we can do it, it should be connected. So, here it should be connected to, what we can do it, it should be connected here to the, as a input here, and we can put somewhere here, we can put the different thing. Different thing means what? We can use the second summand. Okay. So, therefore, what we do it, this part we will show again, but we will have a different pictorial representation here. What we can do, we will have a, we can have firstly M0 Q0, that will be no doubt, that is P0. Okay. Then we will have M1 Q0, M2 Q0, M3 Q0. So, M2 Q0, M3 Q0. So, we should have a circuit here, one will come here, another input come earlier, that is M0 Q1. Okay. So, this should have nothing, it should have output here. So, that is P1. Now, here we have a full adder, one input directly from here, another input is M1 Q1. Okay. So, we have circuit here, one is here, another is M2 Q1. Okay. So, another one, this is 0, we have circuit M3 Q1. Okay. So, what we can do it, this output will come and it will go down, it cannot ripple on the left side. So, then what will be the input here? What we can do it, see, if you see back here. So, here we are adding 3 terms, right here. So, M2 Q0, M1 Q1, and then in the next full adder we are using M0 Q2. This M0 Q2, instead of putting in the another full adder, we can put M0 Q2 this full adder. So, therefore, circuit this will, we can write this one is M0 Q2. Okay. Similarly, here we can write M1 Q2, here we can write M2 Q2. Okay. Now, what will happen? So, here we see we should have a full adder here, full adder here, full adder here, full adder here. Okay. Now, this full adder automatically this one output input will be taken from the this full adder okay. So, here if you see carefully, so this is one term, this will add 2 term, obviously this will add 3 terms. So, 3 terms means already this one is added. So, we cannot do anything, but whatever this M1 Q0 M1 Q1 we added, that carry should be added in the next term. What I wanted to say is here, so whatever the carry it will come from this circuit, that should propagate, and that is it is propagated and then it is adding with this one. So, therefore, this carry whatever the carry it should come, say this is 2 terms, this carry should propagate here and results is coming from here and this input. So, therefore, our circuit will be here what we can do it, this is adding, here we added 2 terms. So, there is a chance that some carry will come. So, carry can be feed here. Okay. And then it has 2 terms. So, therefore, it should be 0 here. Okay. So, we cannot feed on the directly to the this full adder from here. So, therefore, this will come input here, this will come input here. What we will do it? So, here this full adder will come, this one, this full adder will come here, this full adder will come here. And then what do you add it here? This will be M0 Q3. M0 Q3 is started at the 4th bit, right. If you carefully see, so M0 Q3 started 0, 1, 2. So, it is in the 4th bit position. So, therefore, we have P0, P1, P2. So, this will give you the M0 Q3 started here. So, next this will be what? M1 Q3. Now, here this will be M2 Q3, okay. And then this will be M3 Q3, okay. So, then it has all input here. Now, what we have to do it? So, this also will have the output, this also will have output, this also will have output, this also will have output. So, now all summand is completed, all summand are completed, right. So, M0 Q1, okay, M0 Q0. So, M1 Q0, then this one is Q1, 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 this will be Q2, 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 Q3, Q3, Q3 and Q3. So, all 4 summand completed. Now, what we have to do? Now, there will be some output from this full adder. So, therefore, we should have another full adder, output is coming from here, we have full adder, we have full adder, we have full adder, one input directly coming from here. Okay. So, in the last full adder, what we do it? One input is coming from the, so like P0, P1, P2. So, for P3, we will take input, we take input from here, this will be 0. So, this will give you P3. So, one input is coming from here. Okay. So, this will be coming from here, this will be ripple, this will be ripple, P0, this output will be P4, this output will be P5, this will be P6, this will be P7. What is the advantage? Advantage here is whenever this full adder is working, this one, this one, this one all can work together. Earlier, to reach signal at this point, we had to traverse this one 1, 2, 3, 4. However, whenever this output is available at this point, at the same time this output will be also available. This one mark will available at the same time after 2 gate delay, because full adder take 2 gate delay and AND gate. So, after 3 gate delay you will get this value here. So, instead of say 1, 2, 3, 4, 8 gate delay, 8 plus 1, 9 gate delay, you are getting the output after 2 gate delays, and that output will feed here in the lower level full adder. So, this also will take 2 gate delay. So, therefore, each level it will take only 2 gate delays, and the end this is a ripple carry. So, now you at the end last stage what you can do? You can use the carry look ahead error whatever we learned earlier, or we can use the carry ripple carry. If we use ripple carry, after this one this is taking 2 gate delay, this is taking 2 gate delay, and here this will take 2, this will take 2, this will take 2, this will take 2, 1, 2, 3, 4. So, 4 plus 2 plus 2, okay, and plus 1. But if you imagine that number of level increases, so here only increasing 2, earlier you are saying coming here and there, so 4 gate delay, every time you are reducing by 2. And not only that, and the last level whatever we are doing, instead of having the ripple carry, we can go with carry look ahead error. Okay. So, therefore, this is nothing but the addition operation here we learned earlier. So, we can use the carry look ahead error. So, carry look ahead error, what is the gate delay? So, same gate delay we can use adding this 2 plus 2 plus 5, okay, 5 or 3. Okay. Now, what do you do it? So, if you carefully see is here we have sum and carry. So, we will show it one example, but this is a basic circuit for this is something called carry save addition. Why carry save addition? Because carry we are saving and forwarding at the right place, and therefore, it is saving the time propagating that signal from say starting from full adder first to the last full adder. That is why it is called carry save addition. We will show with one example here. Let us say we want to add 2 numbers, okay. Sorry, we want to multiply 2 numbers. So, let us take one example here. Say we have a number 1 0 1 1 0 1. So, this is 45. So, this is nothing but the multiplier 0 1 2 3 4 5 32 0 1 2 3 8. So, 40 0 1 2 4 44, this one 45. Now, we want to multiply all 1. So, this is nothing but 63. So, this is multiplier. So, this is multiplicand. Okay. So, now let us do it. What do we do it? This is 1. So, therefore, we should have a 1 0 1 1 0 1. Then again we have 1. So, what we do it? We have 1 0 1 1 0 1. We are doing somewhere mistake. 0 1 1 1 0 1. So, it should be here. So, 1 0 1 1 0 1. Next, this is 1 0 1 1 0 1. This is 1 0 1 1 0 1. So, 1 2 3 4 1 2 3 4 5 6. Okay. So, 1 0 1 1 0 1 1 0 1 1 0 1. So, this is A, this is B, this is C, this is D, this is E, this is F, and then we can add them. Now, these one we will do using carry shape addition circuit. See, if you carefully observe this point here. So, what is that? We have to group into 3. So, therefore, what we can group it here? These 3 and these 3. Okay. So, in earlier circuit we have a full adder, then one is coming from here, another is here, and another is coming from the earlier level, right. Okay. So, therefore, what we do, this full adder needs 3 input, each full adder needs 3 input. So, therefore, we can combine this full adder and parallelly this one we can do parallelly, okay. And then whatever the result will come, again we can add using full adder. So, therefore, I think one example will be very much clear. So, now we have 1 0 1 1 0 1. So, this is the summand, and because all bit is in multiplier all bit is 1. So, then summand will be the same thing. Now, what we do it here, we these 3, because as we know that full adder needs the 3 bits. Okay. So, these 3 will combine and parallelly these 3 also will be combined. While we are doing operation with these 3, last 3 also we can do parallelly. What will happen? So, for any full adder, what we see is, if we give 3 inputs, so one will be the carry and another will be the sum. So, these 3 input is coming from A, B, C. Say here is, say example here, these 3, one will be 1, another will be 0, another will be 1. So, therefore, we will get the 2 output. So, here we will get carry and sum. Similarly, while doing this part in the parallelly, it will not affect any results. We can do here, we can get S2 C2. Okay. Here this circuit will get this one. Similarly, we can have a multiple circuit here, as we have seen it here for each 3 bits. So, here these 3, say this will correspond to here, this will correspond to 1, this will correspond to 1, and so on. This is number of what is called full adder will be 1 2 3 4 5 6, okay, 6 7 8. Now, again we have 4, again we can combine these 3, therefore, we will get again S3, C3 and again combine here. Okay. So, again we can combine these 3, then you will get S 4 and C 4, and after getting the last 2 vector we can go with ripple carry or using carry look ahead error, or if you have a multiple bit above 8 bits we can go for the higher order generate and propagate function. Okay. So, this one I am elaborating here. Okay. So, here we go, what we got it 1 0 1 1 0 1 1 0. Okay. So, 1 0 1 1 1 0 1 1, then 0 1. So, let us say this is A. Then what is B? B is also same thing, but shifting left. So, this will be 1, this will be 0, this will be 1 1 0 1. So, this will be B. Then C, C will be 1 0 1 1 0 1. So, this will be C. Now, you consider 3 inputs. So, you consider that each bit position we have full adder. So, therefore, what we do? So, here we have a full adder. So, that add this is, let us say this is 0, this is 0, this is 0. So, let us say this is 0, this will be 0, this will be 0. Now, you add full adder. So, what will be the output? Sum will be 1 and carry will be in the next bit position. As you can see here figure, here we are moving here into the next bit position, we are moving in the next bit position. So, therefore, this is the carry. So, we should write it here. So, here 1 and carry should be in the next bit position, carry is 0, 0 1 1 we should write carry is 0, 1 1 0 carry is 1, 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 1 0 1 carry is 0, 1 carry is 0. So, this is nothing but S 1, this is nothing but C 1. Similarly, while doing ABC, we can have a circuit while performing DEF, same thing we will do it DEF parallelly. Okay. So, if you do this one, we will get the same results here. We can again perform the same operation, but you need to maintain this value. So, D started from this position, what which position 1 2 3 4th position. So, therefore, D starting from this is 0 1 2 3 4 5. So, D starting from 4th position, right. So, D is starting from the 4th position, D is here, okay. It started from this position 1 2 3 4th position. So, D is what 1 2 3 4th position here. So, D will be 1 0 1 1 0 1. Okay. So, E will be, is it right 0 1, I think something wrong, 1 1 0 1, 1 0 1 1, no. So, D will be 1 2 3 4th position, though this should be 1, then this should be 0, this should be 1 1 0 1. Then E will be here 1 0 1 1 0 1. F will be from here, that is 1 0 1 1 0 1. So, we will perform only this one. Here this will be D, this is E, this is F. So, now we will add it 1 0 0 1 1 0 1 1. This is 3 term, only this one. So, not this one. Okay. So, 1 1 0 0 1 1. So, output will be 1 1, result will be 0, carry will be 1. 1 1, result will be 0, carry will be 1. 1 1 0, result will be 0, carry will be 1. 1 1 0, result will be 1, carry will be 0. 1 0 1 0. So, this one we can say this is S2, we can say this is C3. Now, what we can do it? We can add S1, C1 and this one done parallelly and S2. So, therefore, what we can do it, because we do not have space. So, we can remove this D, E, F here. Okay. Instead of that, S2 we can write here directly. So, we have S1, C1 and result of S2 we can directly write it here. So, what we can do it? So, as if we did it here and then yeah. So, S2 we can write at this bit position 1 1 0 0 0, how many 0? 1 2 3 4 0. So, this is 1 0, then 1 1, okay. And C3, okay. C3 is starting from which bit position? 5th. So, we write it 5th. Now, you rub it here. So, this is S2. Now, what you do it? You add, not add. What you do? S1 we got, C1 we got, S2. Now, we got 3 terms. Now, we have to add it. So, this will give you 1 and then carry 0. This will give you 1, carry 0. This will give you 0, carry 0, 1, carry 0, 1 1 0, carry 1, 1 1 0, carry 1, yeah, 1 1 0, carry 1, 1 0 1, carry 0, 0 0 0 0, 1 0 1 0. Okay. So, now what we got it results, we got it C3. So, this is S3 and this is what? S2, I think S2 we got it. This is how come it is C3? It should be S2, C2. So, C3 and C3, S3, C3. So, now what we have got? Again we got 3 terms. So, now C3. So, therefore, again we have to add this part. Okay. If you add this one, then what we will get? Again we will get the sum and carry, and those sum and carry will be added in using ripple carry or carry look ahead error. So, what we do it now, this entire thing we have to copy into the next page and then only we can perform, because here we do not have space. Okay. 1 2 3 4 5 6 7 8 9 10 11 12. Okay. How many bits we consider we have here? yeah, 1 2 3 4 5 6, so 12 bits. Okay. Now what you have to do, again you have to perform a operation. So this will be 1, carry will be 0, this will be 1, carry will be 0, this will be 0 0 1 0 0 1, this will be 0 1 0 1, this will be 0 1 1 1, this will be 1 1 0 1 0 1 1 0, this will be 1. Okay. This will be 1. So this will be 1 0 0, this will be 1 and 0. Okay. So now what you have to do, you have to add in a ripple manner. So what will be the results? I don't have option, so this one will be S4 and this one will be C4. Okay. So then what we have to do, S4 is 1 1 0 1 1 0 1 1 0 0 1 0. Okay, let me write here S4 what is coming. No, there is some problem. So I think we should remove this part. So this part again we will do in the next class.